Good morning, folks. Cool. I feel terrible. Started coughing yesterday, a little fever. I don't know if it's COVID. I'll find out today, though. I hope to be back in school tomorrow. I hope you guys are well. Please keep your masks on. All right, so let's talk about what's going on. So yesterday we got into this circle stuff. We did a couple labs, and then we started worksheet 1. And some of the stuff in worksheet 1's a little bit tricky. We'll get to there, but I think what's a good idea for you guys today is to open up worksheet 2 and try to get this done because it'll make worksheet 1 a little easier. This is how you get started on those. So I think this is going to work out pretty well. Here's the deal. The sum of forces equals 0 in a circle. What does that mean? What that means is there must be an unbalanced, uncanceled out force to cause circular motion, uniform circular motion. And that's because it's an acceleration, right? So what we're going to do is we're going to use force diagrams to figure out what's acting on, what kind of forces are present on each of these objects, and then figure out which one of them is causing it to go in circles. So let's get started with this very first one. Here you've got a situation where you've got just like a yo-yo on a table. Somebody's just spinning it around in circles. So we'll do a quick force diagram for it. And what we're going to say here is there's always gravity. And then there's a normal force, and we got to determine, is it longer than, shorter than, or equal to the gravitational force? And in this case, it's not accelerating upward or down, so that means that the normal force has to be equal to the gravitational force. Do either of those forces have anything to do with the circular motion? Not really. Is there anything else touching it that we haven't discussed? Yeah, the string. What kind of force is that, and what direction is that? You got that right, my friend. That is a tension force, and it's being pulled toward the center of the circle. So when I think of everything touching the yo-yo, I think we've got it nailed. That's everything. So now we got to ask ourselves, which of those is causing the circular motion? Well, I think you guessed, or Chester, it's going to be the tension force. So what we know is this. The centripetal force is the sum of all forces in the direction of the circular motion. So the normal force and the gravitational force do not have anything to do with moving in a circle. Only the tension force does. So for this one, we would just say that the centripetal force is equal to the tension force. And then you can start solving problems with whatever you know. Now, in this sheet, you're not going to solve problems. But you can use this mentality to get back to worksheet 1 and talk about it. So let's shrink this a little bit. That's not what I want to do. Get this out of the way. All right, let's go to the other one. This one's weird, but it's good. All right, so what we see here is we've got a car that's going over a hill, and we hope it goes back down again. What we hope doesn't happen is that it goes, woo, like Dukes of Hazzard into space. That's not likely to happen. It shouldn't happen. We want it to go in this circular path to go back down the other side of the hill. So with that in mind, you might say, but that's not a circle. A whole circle would be, going all the way around. Well, you're right. But you don't have to do a full circle to be considered in circular motion. You could just do a little part of the circle to have circular motion. All right, so we're going to do the force diagram again. Always got gravity coming down. We got a normal force pushing up. And I bet a lot of you guys are going to be tempted to say that the normal force is equal and opposite to the gravitational force. People love saying that, but it's not usually true. Well, it's not always true. In this case, if the gravitational force and the normal force were equal, what would happen to the motion of this car in the x or in the y dimension? Would there be an acceleration up or an acceleration down if these two are equal? No, there would not. This would be a situation where you'd get just flying off into space. That's bad. Blow out your shocks in your car. So what that means is that the normal force has to be a little less. And we're going to let gravity pull this car down the hill to make it go in a circle. So the center of the circle is in this direction. So which of these forces have to do with that? Well, both of them. So we'd say this. The centripetal force is the sum of the forces in the circular dimension. So in this case, the centripetal force is equal to the gravitational force minus the normal force. Why minus? Well, because we like to say that positive is toward the center of the circle. And gravity is toward the center of the circle. The normal force is opposite, so we're going to subtract it. So when it's time to solve for the centripetal force, we would just do this work right here. All right, so you guys got to practice this. Send me questions. Talk it over. Work with each other. A lot of good brains in there. You guys can help each other out. Some of these get weird, particularly this one. These two are pretty cool. Look at this one. You've been on this ride where the floor drops out, or you've seen it. Why is that person there? Your force diagrams are really important. All that stuff we learned in Unit 4, it's still relevant. It still matters. Okay, so here's the general approach. 1, draw your free body diagram, your force diagram. 2, determine the direction of the centripetal force. Remember, it's always toward the center of the circle. Then 3, identify which forces are in that dimension. Whatever the dimension of the centripetal force is, which ones that have been drawn are in there. And then 4, write your FC equals sum of forces in the centripetal dimension equation. All right, so you've got a whopping 12 problems to do on this worksheet. I know you can do it. And then if you finish it, I would encourage you guys to go back to worksheet 1 and see if you can use this to solve the problems. All right? All right, you guys, take care of yourselves and wear those masks. Hopefully I'll see you tomorrow.